Welcome everybody. Today I'm going to talk to you guys about acceleration. It's something that we've talked about a little bit in the past. Most often when we've referenced it, we've called it changing motion. So we're going to make it a little bit more mathematical, a little bit more clear here in this video. So just to kind of recap, we started off last unit with this idea that there were these things called balanced forces. And these balanced forces, like this weight and the normal force right here, cancel each other out. And so as a result, they don't really have any effect on the motion of the object. That's not to say that the object is stopped. It just means that the object has nothing that can change its motion. So the effect that the weight could have given it and the effect that the normal force could have given it are canceled out by the other. So as a result, they end up not having any effect on the motion at all. So we say there's no net force, and then in mathematical terms, we'd say there's no change in velocity, which is what we have here, change in velocity. If, on the other hand, you have this situation right here, where you have unbalanced forces, where the normal force and the weight do cancel out, but then the applied force and the friction force do not cancel out, we have some additional force left over. If you take this tiny little force here and cancel out some of that applied force, you'll see that there is some left over. And that sum that's left over is what we call the net force. It's the force that is left over. And in this case, it's about this much to the right side, like so. That's the net force, and we write it F sub net, like so. It is the thing that causes a change in motion. And so anytime we talk about a change in motion, we're really talking about this delta V, the amount that the velocity changes. And you can see that the velocity is going to change to the right. And that's, of course, because the net force is causing that change to the right. And so as a result, we have this delta V, this change in velocity. So the motion is changing. Now, if we wanted to, we could say, we could compare that delta V to the amount of time that it takes to change. And we could come up with a very useful idea, very useful concept, very useful calculation, and that is the acceleration. So we can measure the delta V and compare it to the time that's elapsed, which we would say is delta T, and if we divide those two, we end up with how fast the velocity is changing, which we would call the acceleration. So the acceleration can be, in physics, can be speeding up, it can be slowing down, or it can be changing directions. And the reason for that is that it's a vector. So acceleration is a vector. It does take into account the direction in which the motion is going. For speeding up, we would say that's a positive acceleration. For slowing down, we'd say it's a negative acceleration. And so changing direction, we really could go either way with that on how that's written out. The formula for acceleration is a pretty easy one. It's A equals V sub 2, which is the final velocity, minus V sub 1, which is the initial velocity, divided by the amount of time that has elapsed. So the easiest way to do that is to take the last time and subtract the first time and figure it out. Now, oftentimes, the first time is actually 0. If you're smart about how you make your calculations or make your observations, you can see that that's actually 0. And that oftentimes is the case. It's not always, so you have to be careful. I'll be honest, I don't like to write things out like this too often because I'm pretty lazy. So the easier way to do that is to say A equals delta V over delta T. That's the definition of an acceleration. The change in velocity over the change in time. So that's how it works. Hopefully that makes sense.